What is the mathematical elegance of Python line graph smoothing? Imagine turning a jagged mountain range into a smooth, flowing landscape with just a few simple tools. That's what line graph smoothing does in data analysis and visualization. It takes noisy, uneven data and transforms it into a clean, easy-to-understand curve. The magic behind this process is rooted in solid mathematics that balances accuracy with simplicity. One popular method is smoothing splines. Think of them as flexible rubber bands stretched through data points. The goal is to find a curve that stays close to the data but isn't too wiggly. This is done by minimizing a function that measures how far the curve is from the data and how smooth the curve is. The key is a smoothing parameter that controls this balance. When the parameter is small, the curve fits every data point closely, which can make it jagged. When it's large, the curve becomes smoother, sometimes approaching a straight line. This approach uses optimization techniques to find the best balance, making it both mathematically elegant and practical. Another method is the Savitzky-Golay filter. It works by fitting small sections of data with low-degree polynomials using least squares. Imagine sliding a small window across your data and fitting a tiny curve within that window. This preserves important features like peaks and valleys better than just averaging nearby points. You can control how smooth the result is by changing the size of the window and the degree of the polynomial. This makes it a flexible and mathematically sound way to smooth data while keeping key details. Moving averages are simpler but still effective. They smooth data by averaging a fixed number of neighboring points. It's like taking a small group of data points and replacing them with their average. This reduces fluctuations but can blur sharp changes. It's easy to implement and quick to run, making it useful for quick visualizations. Exponential smoothing is another technique that gives more weight to recent data points. It uses a recursive formula to combine new data with past smoothed values. Think of it as a weighted average that emphasizes the latest information. This method is especially good for time series data where trends and patterns change over time. Its mathematical beauty lies in its simplicity and the way it naturally discounts older data. In Python, these smoothing methods are available in libraries like SciPy and NumPy. You can apply them with just a few lines of code, making it easy to improve your line graphs. For example, using SciPy's spline functions or the Savitzky-Golay filter, you can quickly turn noisy data into a smooth, clear picture. This not only makes your graphs look better but also helps you see the real trends more clearly. In essence, the mathematical elegance of Python line graph smoothing comes from using optimization, polynomial fitting, and weighted averages. These methods are grounded in solid math principles and are simple enough to use in everyday data analysis. They help you create smooth, meaningful visualizations that reveal the true story behind your data.